Last time, we talked about using PWM pins and analog input pins on the Arduino, how analog values work, and how to use a potentiometer to control the input values and control the brightness of an LED. So today, we're going to learn new things and apply it to the same project to make it more fun. First, introducing you to an ultrasonic sensor. This is specifically an HC SR04. This is a very common, typical ultrasonic sensor. We're going to be working with this. As you can see, it comes with 4 pins, and they are VCC, trig, echo, and ground. So, let's quickly connect the VCC and ground that we are familiar with. Again, the ground goes inside of the ground of the Arduino, and VCC goes to 5 volts. 5 volts is perfectly fine for this. Now, for trig and echo, we're going to put them in just normal pins of the Arduino. So, we're going to just plug both trig and echo into 3 and 2. So 3, that's the trig, and 2. Perfect. Once you have made this connection, let's go to Arduino IDE. Before we start coding the ultrasonic sensor, let's talk about something else that is very important. In setup, type serial.begin 9600. So what this line of code does is that it sets the bits per second transmitted to the serial monitor to maximum 9600 bits, which is the default for Arduino IDE. Having a higher value would result in having to shorten perhaps the cable length to accommodate for the more bits per second. Now, this then allows you to print things in the serial monitor. So what we can do is to use serial.print hello world. If we just quickly run this upload, you can see that you cannot see anything. So now what you would do is that you have to pull up serial monitor on top in tools and serial monitor. As you can see here, this is printing hello world in a loop. Now, with print, we also come with something called print line. So let's just comment that out. So comment out just means it's no longer valid. We're using 2 dashes to make this a comment rather than a code. And instead of serial.print, we go serial.println and do the same thing. As you can see, my serial monitor is now here, and it just outputs hello world in a new line each time I go print line. We can also work with this print function on the serial with values. Let's say we have an integer value that is equal to 0. And each time that we print out this value, so we go serial.println value, each time we print out this value, we add this value by 1. Value equal value at 1, and this keeps looping. So if we try this, as you can see, we're going down with all the values. So what this means is that we can not only just print strings, which are just texts, we can also print values or integers, for example here. so that we can see the values.
All right, now let's get into the coding for our ultrasonic sensor. First, as we remember, we have to name our pins. So we have the trig pin at number 10 and the echo pin at pin number 9. After that, we would want to set them up in the pin mode or the setup function with the function pin mode. So pin mode, trig pin, output, and same thing for the echo pin, but as input. This is because, as I have explained before, the trig pin works as a transmitter and the echo pin acts as a receiver. So once the receiver has received the data, it has to send the data it has collected to the Arduino, right? So your Arduino's port has to be set as an input for it to get the input from the echo pin. After that, let's create a value called time, float time, and a value called distance. Now, we use float because it allows us to have decimal answers rather than integers. So we can have outputs like 15.3 centimeters rather than, say, like 15 centimeters, which is more accurate. Now, next, let's look at the loop. So, first, we want to clear the trig pin because the trig pin the transmitter is consistently sending packs of these signals. We want to clear it in the beginning of the loop each time it loops back. So let's go digital write trig pin low. So we're just turning it low so we can clear it. It's not transmitting anything. And we do that for 2 microseconds. Then we're going to let it send the data, right? Or sorry, let it send the signal, right? So now we're going to turn the trig pin up to high. After we turn it up to high, we're gonna let it stay sending these signals for 10 microseconds. So 10 microseconds allows exactly 8 bursts of these signals to be sent. All right, and after that, we turn the trig pin to low again. So we only send 8 bursts and we turn it back to low in each loop. Now, after this is done, we want the echo pin or the receiver to receive or to try to receive to see if there is anything, any signals reflected from if there's any objects in front of the ultrasonic sensor, right? So let's say there is an object 20 centimeters in front of the ultrasonic sensor and we sent 8 bursts of signals on top of it. It's going to be bounced back and the receiver would receive it. So what we have to do first is to turn the receiver to high to let it know that, okay, I should start listening to the signals and see if there are signals coming in, right? And we do that with a specific function called pulse in. And we want to turn it to high. So what this does is that it tells the receiver to listen for reflected signals, basically. And this also gives back a value. And this value is basically assuming that the echo pin has received the data, how long time has passed since it has been turned on. So let's turn the float time into this data. Let's store this data in time. So what this means is that after the echo pin received the received the signal after it has been turned on, it calculates the exact amount of time in probably microseconds and store it in this value. And hopefully in physics you have learned distance is equal to speed times time. And in this specific case, we have the speed of light. So what we're going to do, same equation, we have distance over here, right? So we have distance equals the speed of light, which is 0.034. And that is the speed of light in centimeters per microsecond. And times time, which is, we have already found time from the pulse-in function, and divided by 2. Now, first, 0.034 is equal to speed of light in centimeters per microseconds. And we divide by 2 because there and back, right? To account for the there and back. So because to travel to the object and back to the object, it travels twice the distance, we're going to divide it by 2 so that we get the actual distance, not the there and back, which would be double. And finally, we're going to delay for 1 second and do everything again. So this is basically it for our ultrasonic sensor. Now, the problem is, how do I know what value or the ultrasonic sensor is getting, right? And that's when we use the serial monitor. As I've just explained, let's first in the setup do serial.begin 9600 bits per second. Nice. And after that, in the loop, after we figure out the distance, let's go serial.print. The distance is space, and another serial.print. The distance, the actual distance that we calculated in centimeters, and another serial print that prints out centimeters, so it tells the unit. And finally, we do serial.println. So the print line just ensures that we don't just have the values keep going horizontally, or in other words, we have a new line for each. The distance is, say, 15 centimeters. Okay, now it goes to a new line. This just goes to a new line. And that would be it. Let's upload it to our ultrasonic sensor and see if it works.
As you can see, that has been successfully uploaded. Now, if I go to Tools, click Serial Monitor, as you can see, the serial monitor has popped up. And if I put my hand right on top of the ultrasonic sensor, the reading is becoming 8 centimeters. As you can see, now it's 5 centimeters, 8. If I move it a little bit farther, it's reading 13. Even farther, now it's reading around 22. So play around with this with your hand, see how far and close it can register. Usually the best optimal range would be around, I would say 2 to 40 centimeters. When it gets too close, the reading gets messed up. The receiver can't really receive the signals. And it really gets too far. I don't think it works as well. When I guess it still does work, but the reading might get messed up at times to time. Now that we have learned how to use an ultrasonic sensor, I have a challenge for you. Try to see if you can combine what we learned with LED with ultrasonic sensor, and make a mini project that turns the green LED on when your hand is 20 centimeters or closer to the ultrasonic sensor, and turn a red LED on when it is farther away. Now, this is my solution for this challenge. First, on a breadboard, I have set up 2 LEDs, one green and one red with 2 resistors. Now, instead of jumper wires, I've used these small connections, but I've made the connections from the negative side. So I have all the positive side on the right to the negative side on the vertical line of the breadboard. So now what I'm going to do is that I'm going to unplug, first of all, the ultrasonic sensor's connection to the Arduino, create 2 new connections for both ground and 5 volts of the Arduino, and connect that to the 2 rows of the breadboard, as you can see here. So I will connect the red to the red row, and the ground to the blue row. So what this does mean is that this entire red row shares the same 5 volts, and this entire blue row, or the negative sign, shares the entire ground. And since all the grounds of the LEDs are connected here, I only used one jumper wire to take up one spot on the Arduino to share the grounds of all of the LED. Now, I do have to use individual jumper wires to connect the LED to the Arduino. But first, let's plug the 5 volts or VCC and ground of our ultrasonic sensor to the connector rows. So I will put this here. Whoops, wrong side. Put this here, and this on the other side. And when you work with multiple resistors like this, try to not make them touch each other. That may cause issues with your LEDs when they're too close together. And now let me grab two more jumper wires. Great. Now I will connect the positive side of both LEDs to number 12 and 13 of my Arduino. So 12 is the green LED and 13 is the red LED. Now the connection is complete. For the code, let's first name the variables. So we had int LED green, and that is, let me remember, number 12. Yep, number 12. And we have int LED red, which is number 13. And let's do the same thing in the pin mode. I'm just going to copy this line. LED green, LED red, both are output. Now here we're going to use an if statement. We're going to use an if statement after the print line of the distance. So how if statement work is that let's put if first. In a parenthesis, we put the statement of if what happens. So in this case, we're looking at if the distance is less than 20 centimeters, right? So we just do if distance smaller than 20 centimeters. Whoops, than 20. We don't have units here. And we have a curly brackets. Open it up. What we're gonna do is to turn the green LED on. So we're going to do digital write LED green high. Now else, so else means if it isn't smaller than 20, so every other case, we're going to digital write the LED red to high. Now one problem that you might notice is that what if, okay, for the first register, okay, this is high, and for the second register, this is high. But now both are high, right? So what we gotta do is to copy both code. And when we turn the red to high, we gotta turn the green to low. And when we gotta turn the green to low, when we get to turn the green to high, the red LED has to be low. And now, this should be it. Let's try to upload to our project. As you can see, the upload has been successful. So, if I grab the ultrasonic sensor, currently the green LED is lit up. If I put my hand close to it, supposedly, if it is too far, the red LED should be lit up. I have found the mistake in my code. Let me explain. So, instead of plugging the ultrasonic sensor's 5 volts to I replugged it back to this 5 volt for a second, and after I plugged this back, it started working. There might be some issues with the ultrasonic sensor's registering of the voltage, but now as you can see, it is working properly. If I take the ultrasonic sensor, if I put my hand here, as you can see in the log, it says 17, around 15 to 16 centimeters, and the green LED is lit up. If I move my hand farther away, now it's reading around 21, and the red LED is lit up. And as I inch my hand closer, green, red, green, and red. Great. Now you have completed this LED ultrasonic controlled LED project.